When your car goes meep, 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 you know that you have to put on your seatbelt. And when your oven says whirly beep, you know the souffle is ready. And when your washing machine goes beep, you know it's time to put the load in the dryer. That's because we have learned how to speak computer. Now we want the computer to learn to speak English, or whatever your language of choice might be. But you know that's a complicated problem because of how frustrating it can be to talk to Siri or Alexa or Google. We've been working on this since the start of AI. Alan Turing, who wrote that first paper about thinking machines in the 1950s, developed a test, and it is known as the Turing test. The setup is a person in a room with a terminal, communicating with either a machine or another person in another room. The test is whether the computer in the other room can fool the tester into thinking that they are in communication with another human just through text. You've chatted with enough chatbots and enough smart speakers to know that they fail pretty often. Why? Because human speech is not only a complex mix of vocabulary, grammar, context, and tone, it's also a matter of inflection. Here's an example of inflection that proves the human voice carries a lot of signal. Listen to this sentence. I never said she stole my money. That 7-word sentence can have 7 different meanings depending on where you put the emphasis. I never said she stole my money. I never said she stole. I never said she stole my money. I never said she stole. I never said she stole my money. I never said she stole my money. See, it's a tough problem. That's why robots sound robotic. Humans are nuanced, machines are not. So before robots take over the Earth, they're going to have to sound a whole lot more convincing than they do now. Sure, we can get a machine to sound like a human as it reads text, but there's something human missing. We may, however, be ready to cross the uncanny valley. That's the term for robots that have made it from obviously robots to, oh my God, that's so weird, but haven't made it quite to, really, that's a robot? Yet. Take, for instance, IBM's Watson text-to-speech voices test. So you can see that artificial intelligence is becoming better at this because AI isn't just programming a bunch of instructions and rules into the computer, it's a way for the machine to learn. The computer can learn how to emphasize one word or another to simulate a specific meaning, but when it's tested in the field, it can improve its performance. An example of a machine that seems a lot like a person, Google Duplex. Given a very specific task, it can fool some of the people some of the time, like making a restaurant reservation for you over the phone. The virtual Google Assistant will actually call a restaurant on your behalf, speak with a human on the other end, negotiate the time and number of guests, book the table, alert you when the reservation is made. This is complex AI technology that's now relatively ubiquitous. If voice technology intrigues you, there's a great deal of research going on that you can plug into. Hey Siri. Search for voice technology internships.
Okay, I found this on the web for voice technology internships. Check it out.